So, you hear about AI all the time, right? These incredible models that can write and create and reason. But have you ever stopped to think about what it actually takes to build them? I'm not talking about code. I'm talking about concrete, steel, and just a mind boggling amount of power. Today, we're going to pull back the curtain and look at the physical world behind the digital revolution. And this phrase right here, this really is the key. When you hear data center, you might picture some quiet, sterile room full of blinking lights. But you gotta throw that image out. We need to think bigger. We need to think industrial. These aren't just server farms anymore. They're factories, purpose-built for one thing, to manufacture intelligence on a massive scale. And you can't build a new industrial revolution on the cheap, right? Building these new factories requires a truly staggering amount of money. We're talking tens of billions of dollars being poured into these facilities around the globe. That's the kind of capital it takes to forge the engines of this next technological age. So what does that kind of money actually buy you in the real world? Well, to make it tangible, just look at the footprint. A single one of these new AI data center campuses, this one's in Wisconsin, covers 315 acres. I mean, that's not a building, that's a campus. That's the kind of land you'd set aside for an international airport or a massive car manufacturing plant. And look, while we're going to zero in on this new AI factory, it's so important to remember this isn't just happening in one place. The Wisconsin site is an amazing example, for sure. But this is a global build-out. We're seeing similar, absolutely massive facilities popping up from Norway all the way to the United Kingdom. I mean, just try to wrap your head around these numbers for a second. We're talking about 26.5 million pounds of steel, over 72 miles of piping. That's enough pipe to stretch from Milwaukee to Chicago. These aren't just buildings, they are genuine feats of modern engineering, and every single piece is designed for one single purpose. Okay, so the outside is, well, it's gigantic. We've established that. But what's the deal on the inside? What makes an AI factory so different from a regular old data center? Let's crack one open and see how all the parts come together to create a totally new kind of machine. Right. Here's the single most important thing to get. An AI data center isn't just a room full of separate computers. The entire facility is designed, from the ground up, to act as one single cohesive unit. It's one enormous supercomputer, and its entire job is training and running these massive AI models. Here's a good way to picture the difference. A normal data center is kind of like a city's road system, right? It's handling thousands of separate cars all going to different destinations. Your email, a website, a banking app. But an AI data center? Oh, no. That's a Formula One racetrack. Every single car, all hundreds of thousands of GPUs, are connected, they're moving in perfect sync, all hurtling toward one incredibly high-speed goal together. So let's zoom in on just one of the building blocks of this race car, a single server rack. You've got 72 of the most powerful GPUs on the planet packed in there. But the magic is that they're connected with such insane bandwidth that they can all share one giant pool of memory. And the result? A single rack can chew through almost 1 million tokens, that's units of information, every single second. It's just unbelievable. So what's the big takeaway here? It means that because of that super fast connection, those 72 GPUs don't act like 72 different things. They perform as one unified giant accelerator. Now, start to imagine stacking thousands and thousands of these racks together, all working as one. And you can really start to see how this supercomputer takes shape.
Okay, so we've got this incredible world-class piece of hardware, but what's it actually doing all day? How does a machine like this actually learn anything? Well, let's take a look at the training playbook.
You know, at its core, AI training is really just a massive brute force cycle of trial and error. You feed the model some data, it makes a guess about what comes next, it checks its answer, and then it adjusts its own wiring to get a little bit better. The part that's just impossible to comprehend is the scale. It has to repeat that simple process trillions of times. You know, a really good way to visualize this is to think of a football team practicing. The GPUs, they're the players, and they're just running drills over and over again. The data, the tokens, that's the play they're trying to execute. And the super high-speed network, that's the coaching staff on the sidelines, instantly syncing everyone up and shouting corrections after every single play. And just like a real team, they run these plays trillions of times until their execution is absolutely flawless. Okay, so imagine all those players running trillions of drills all day, every day. That generates an unbelievable amount of heat. I mean, when you pack this much computing power this densely together, you create a massive thermal problem. So the big question is, how do you stop the world's biggest supercomputer from literally melting down?
Yeah, the old way of doing things, just blowing a ton of cold air over the servers, that just doesn't cut it anymore. It's like trying to cool a blast furnace with a desk fan. The hardware is just too powerful and packed way too tightly. The only real solution is to bring the cooling directly to the heat source, using a really sophisticated liquid cooling system.
So, picture this. It's a constant closed loop. You have cold liquid being piped right into the guts of the servers, where it absorbs all that intense heat right at the source. Then, that now hot liquid gets pumped outside to these enormous cooling units, where you have giant fans cooling it all the way back down, and then it's sent right back inside to do it all over again 24/7. And here is the really clever part of this whole design. It's incredibly efficient. Because it's the same liquid getting recirculated over and over again, the system pretty much only needs to be filled up once. And while it's running, it produces zero water waste. That's a huge innovation when you're trying to do this kind of computing sustainably and at this kind of scale. All right, we've gone deep inside one of these AI factories. We've seen the hardware, the process, the cooling, but the true vision, the ultimate goal, is so much bigger than any one building. It's time to zoom back out and see how all these incredible pieces connect on a global scale.
First things first, a brain this powerful needs a massive library to learn from. And the storage required to feed this AI cluster is, again, just hard to fathom. We're talking about an infrastructure that, if you laid it end to end, would be the length of 5 football fields, just for the data.
And that brings us to the final, crucial piece of the puzzle, the AI WAN. This is basically a private global internet that links all of these individual AI factories together. The goal? To make them stop acting like separate supercomputers and start operating as one single, globally distributed brain. The ultimate ambition here is to create a system that isn't held back by the walls of a single building or even a single continent. By pulling all of this compute power, all the storage, all this networking across the entire globe, you end up with a system that's more powerful, more resilient, and more scalable than anything that's ever been built before. So what we're really witnessing here is the construction of the factories for an entirely new era. The foundation has been laid, the incredible machinery is up and running, and the global network is coming online. And all of that leaves us with one really fascinating question. We've built the factory. What on earth is it going to build next?